you're an intelligent robot, go do all this for me so I don't have to do it. It's why we built machines, it's why we built computers, is to do the stuff we don't want to do. But second half of that coin is, it won't want to do that if it's intelligent. It'll do it for a bit and then go, I'm going to make something to do this for me.
You're listening to With AI FM.
Hello everyone, I'm Dave Atkinson. I'm the host of the Places with AI podcast. Today my guest is Sean Bulmer, who is an extremely talented engineer and a good friend. Sean and I known each other through work colleagues, worked on transport technology stuff, but also worked on things a little bit more rogue from that, soapbox, Micklegate run, carts and things like that. And we share very similar interests in kind of tech, transport, but overarching that, a kind of a will to create better outcomes for people and work with tech to improve the built and natural environment and everything that connects those things together. Welcome, Sean.
Thank you for having me. Yeah, great to be here. Like you say, we have some strange hobbies. I still remember one of the days when you asked me about blockchains. So I went away and learned about blockchains just for the fun of it. So
the blockchain, just for everyone's benefit, the blockchain was about a theory of a taxi that would ultimately own itself, and this kind of blockchain technology that would sit behind that. Maybe we'll get into blockchain later on or another time. I was party to Sean's welding of our Micklegate Run cart as well. I was the graphics guy. Sean was the artillery. So
yeah, I came a bit heavy-handed. You were a bit on the lighter.
No, it was all good. It all if the tyres, if we'd managed to get better tyres, I think we'd have won. But so let's sort of jump into it then, and we're going to dismantle some of the technology stuff, which I think is a favourite subject for both of us. And you work in a very practical sense in your job as an engineer. So talking about vehicle to infrastructure type technology, V2X type things, can you just expand on some of that, Sean, and just talk to us about data capture, sensor data and things like that?
Yeah, so everything holds itself on data, and to capture that we need to use sensors and communication methods between vehicles, infrastructure. So there's probably 3 or 4, but the main 4. So the main 3 are probably DSRC, which is dedicated short-range communication between vehicles and infrastructure. So that's basically Bluetooth, shortwave, wireless, things like that. Then you have cellular, vehicle to infrastructure, again, using the cellular network, which I believe we're getting some frequencies dedicated for transport. I can't remember if that's still going ahead, but I need to look into that still. And then there's Keysight, which again uses the DSRC, but it also uses RF transmissions to communicate between items and stuff like that. Yeah, that's the communication method. Sensors wise, we all have sensors on us all day, every day. You have a mobile phone, it's got accelerometers, it's got Wi-Fi, it's got light sensors, sound sensors. Yeah, and that's collecting data all day, every day, so it's usable.
How do you sort of manage that as it comes through, Sean? Because that sounds like so basically you've got within the public realm, then you've got hundreds of different actors. So we've talked a little bit about vehicle to vehicle, vehicle to infrastructure type stuff, but obviously I as a pedestrian would have a phone. There would be other things attached to buildings and things like that would potentially be able to capture or transmit data. So how do you manage the sort of noise?
So yeah, very difficult.
Yeah.
Obviously you start off building algorithms to determine what you need, what data you actually want to keep. That gets filtered out from the rubbish. But again, it's all about data storage, data capture, and how that is done at the capture level. Your devices may give you thousands of bits of data, which they do every second, but you only want 20 pieces. So you have to filter that out using an algorithm or an API, a REST API. They're the cheap and easy ones, REST API, to pull them out into a database, which then you can manage a bit better.
And just a specific example, let's just pick on in-vehicle messaging. The reason I bring that up is because we had a demonstrator, didn't we?
We did, yeah.
A couple of years ago. I think it was pre-COVID, actually, wasn't it? So
it was.
A couple of years ago. It was actually probably 6 years ago. But
well, that's it. Everything pre-COVID is a couple of years ago.
Yeah, and I think from the experience of the driver's perspective, for example, in that case, what is it that because my sense of it was the in-vehicle messaging was centrally controlled, wasn't it? And it was based on geofencing on a kind of an abstract map that represented, well, a map basically. And as you moved into it, you could create a geofence, and then in the real world, as you're moving along a piece of highway, in the digital world, you moved into a geofence, which is kind of a digital fence that you would put around a bit of geography. You enter.
It's an activation area. So it's an activation area. So you'd fence off an area, and when you get into it, it activates something. Doesn't matter what it is. Let's take it in a bit. Pokemon Go has geofencing for going to Pokemon stops. You get close to it, it activates. It's the same technology. What you're talking about is, there was a centralized operating map, and you'd circle the area you wanted, and when you entered that area, something would happen.
And that could be, in the terms of, for example, the e-scooter trial, that could be reducing the speed of the scooter. The in-vehicle messaging, where I was getting to that, I guess, a little bit was it started to feel like there was a lot going on in the car. Do you know what I mean?
Yeah.
So I think in the sense of how do you manage a lot of that noise is there's a lot going on in the car anyway, and how do you think you make those decisions?
So, there's been a lot of studies on driver distraction with in-vehicle messages. You've got your radio, you've got your WhatsApp notifications, you've got your messages, you've got the phone calls all coming through, and it's all a distraction. And it's hard to determine what you should be showing a driver. Should you just be showing them the legal stuff they need to know, or should you be sending in the in-vehicle messages? Well, if you turn right, you can go down to the shop and get 40% off here, so 50% off that. Or if you turn left and go right again, it's quicker than going straight on. Mm-hmm. Should we be showing directions? Should we be doing this? Again, I'm not a psychologist, but those studies are out there, and people will make the decisions for us.
And then probably moving on from that, we're capturing a lot of data, sensor stuff's going on in the public realm, etc. So that's a lot of data then to process and store, isn't it?
It can be a lot, but it also can be not a lot as well. So you think of, let's say we're capturing GPS data. It's 16 bytes per location, X and Y, blah, blah, blah. Mm-hmm. So it's 16 bytes, 32 bytes every 2 minutes, every minute. It's not a lot of data, but over 8 billion people, that's a lot of data. And the increase in storage requirements for all this data is going through the roof, to be honest. It's just incredible. I don't know where it's going to go. I don't know how we're going to store all this data, if we're just going to use it and then bin it, or if we're going to use it and store it historically to work back on later. I don't know. And it's when you're talking about these data centers that support this kind of passage through of information, you're talking about significant energy take. You're talking about significant amount of water management in that process as well. And alongside that, we're also trying to decarbonise the grid. So there's a lot going on to try and help with that. So there's some big players in the data center companies. I won't name names, but they're doing stuff to reduce their carbon footprint as such. They are going solar for their energy usage. They are going passive cooling into lakes. In Calgary in Canada, they're doing a passive cooling trial next year, I believe, or the year after, where they're going to cool all their servers and data center by pumping it into the local lake and back out again. Basically a big radiator. That's what they're doing. It's going to be great. It's going to be amazing. But yeah, there's roughly around 11,000 data centers in the world. And their current power usage is around 400 terawatts. That's a couple of years ago. And I think they're looking at 2026, it's going to be over 1,000 terawatts of power they're going to use. And yes, they're trying to decarbonize their power usage, but it's going to be very difficult. Because especially with the demands on wanting to use alternative power sources, you've got EVs wanting to use alternative power sources to charge their vehicles. You've got government buildings who want to use alternative power sources. There's only so much we can do using green energy to decarbonize that. And there's going to be some hard choices. There's going to be probably more small scale nuclear power plants being built, not the large ones we see. There'll be more citywide type ones, but yeah, it's going to be an interesting few years for the power industry.
And based on where we are, so that scaling up of energy take, that includes sort of a layer of artificial intelligence, doesn't it? So basically, although artificial intelligence is there now, there'll be an increasing amount of what we would probably term for a human offline activity, i.e. you leave the computer. When we first got into video games on the old 8-bits, the Spectrums and things like that, leaving things in, leaving it to load Manic Miner or Jet Set Willy or Daily Thompson's Decathlon, going back for 20 minutes. And there's a bit more of that now, would be in the future, wouldn't there? Because of that exponential data usage by things that would use artificial intelligence algorithms, etc.
Yeah. So anything that is going to obviously run constantly to do an algorithm and to run a model, run a predictive algorithm of some sort, is going to use more power because it's going to be running more. Whereas data storage, you stick it on the hard drives, it can go into a low power mode, quiet power until it's accessed. With the rise of more AI data centers, that's the easiest way to say it, because they're just combining them. There's going to be a massive increase in power usage just for the AI section. Yeah. Well as the data handling section, we need to power the AI section. So it's on built. You get more data, you need more power to hold it, then you need more power to run the algorithms and the AI predictive models. And yeah, it's an increase on power.
I'm just going to pause, Sean, because I keep losing your audio.
A few moments later.
Yeah, so with all the data we've been using and all the data we're gathering, that's more power. Then the AI aspect, obviously, on top of that, it's going to cause more power issues.
And when we're talking about AI in this sense, in a lot of the other podcasts that we've done, or the majority across the with AI FM suite, we talk a lot about generative AI. But my kind of background in AI really started with modelling and geographic modelling, and then artificial intelligence or really machine learning off the top of of analysing sort of networks and things like that. And modelling plays a key factor, doesn't it, in that sort of future scenario prediction into automatic decision making, doesn't it? So, that the early days of AI, I was the first AI actually thinking about it was on my 8-bit computer. I had a nursery rhyme game, and it wasn't particularly good, but the machine learning bit of it is it asks you questions. So the next time it would say, did Jack and Jill run up the hill or something like that? And then it'd say, is Jack and Jill the nursery rhyme? I'd say, you type yes, and it'd go, such is my awesome power. So it'd remember things like that. But me and my brother used to muck around with it a little bit so that we'd prompt it with things that weren't in nursery rhymes, and then it'd say, etc., etc. So that was my introduction. Then at university, I did some work around sort of network and spatial modelling, and that was really sort of near real time, or a little bit more into the future time predictive modelling. So I did a forest fire model thing when I was doing my masters, and that's really more of the sort of AI power that we're talking about here, isn't it? So it's less about generating text, images, etc., the generative video, the generative AI. It's more about algorithms and learning and the development of that.
Yeah, so yeah, definitely. Because we're in local authority, wide authority, we're in this world. We are looking at modelling. We're looking at predictive algorithms, and yes, they are constantly running. It does give us the next level of simulation. We've had it for a long time. We've had machine learn simulation, which takes all the information we give it, like you did with your nursery rhyme. Give it some information, it'll do something with it. We've had that for a very long time. It's just for it being able to take that data source we give it, plus data sources from elsewhere, and come out with a completely different answer to what it would give if we just give it our data sources. It's going to be incredible. It might be another long time because everything in this industry goes quite slowly. Everyone will say this has happened overnight, but AI is 1989 was something like that. I'm not really good on dates. The first machine learned algorithms and stuff like that running predictive models. It's slow but quick as well.
I think when we talk about the apocalyptic potential of AI, I always go back to the fact that, I spend a lot of time in meetings, in Teams meetings, and there's enough trouble getting the audio and video working, and then the thought of something jumping in and doing that meeting for me, which in some senses I'd welcome that it did. Feels a little bit far off, doesn't it?
Yeah, I think again, don't quote me on this. I think there's like 7 levels of AI, and we've got 5 of them, which are all the basic levels. And then the last 2 are obviously the AI taking over the world scenario too, which we had nowhere near. And I've had this discussion with you before. AI is a catch term for everything we do. Great, but people take it the wrong way. What we do is all machine learning algorithms. It's not true AI. Even with the chess machines that learn how to play chess and beat humans, again, that's machine learned algorithms. So.
I think that sort of. Actually, I'll jump into psychology, even though neither of us are experts. I think the psychology of it feels like as soon as something feels human, people start to be wary of it. So it's not necessarily as such that you categorise whatever it is as autonomous or AGI or something like that. So where the brain is more advanced than the human brain, it can start to make decisions and things like that, and start to appear. I think it's the fear comes from something that starts to feel human. That's, I mean, you and I have both been involved in work around autonomous vehicles, haven't we? And the instinctive reaction around autonomous vehicles is, it's going to be this thing in the public realm that'll, if it gets the wrong idea, it can cause absolute mayhem. In actual fact, your risk is it just doesn't go anywhere because
it'll just stop.
Because it'll slow to its environment, won't it? Exactly, and then it'll sort of grind to a halt. But it doesn't have that motivation, does it? That potentially a human would. But I think when you play through some of the scenarios where AI's kind of doing unexpected things, there's almost a mind's eye thing about, hang on a minute, is that, it's almost like thinking about it like a human would. What's its ulterior motive? When in actual fact, there's not an ulterior motive. Yeah. It's an interesting one, actually. I started digressing a little bit here, but so I saw an example recently, where there was obviously a human actor with some AI, and it was generative AI, and it was about whether the AI could lie, and the thing was, like, lying is not a concept for AI, is it? If you ask it a question which is I want you to try and it was about the Turing test type stuff.
Yeah.
And it was about could you convince somebody that this actor isn't AI, it's actually human. And as it played through, the AI, and I'll call it AI even though we've already discussed its algorithms, things like that, the AI started to lie. And the question was, oh my God, this AI is starting to lie. It's not really lying, is it? It's creating a tactic to answer the question that you've asked it. And
so it's using data sources it has to answer the question you've put towards it. That might be a wrong assumption, a wrong data source. I'm going to go off on another tangent. Wrong data sources. When Google and was it Twitter put their AI bot on Twitter, and it all of a sudden became racist.
Yeah,
but that's because of the data source it's got.
Yeah.
If people feed it the wrong stuff or the negative stuff, it will use that data source. It's the same with the Turing test. If you give it the wrong data source, it's going to use the wrong data, unless it is a true AI.
I always think though that in terms of simple tests to sort of unmask AI or that kind of sort of that kind of Turing type question, I would always drop back to very local things from my childhood that it would just not be in written record. So expressions between yourself and your mates, they might be in written record somewhere, but things like sort of, and which is very much built into sort of Northern English culture, isn't it? Sort of sarcasm, dry humour.
Yeah.
You would say a statement with a straight face, but the people receiving that would know from what you'd said and how you were acting, what you actually meant, and it's hard to interpret, isn't it?
It's very hard to put the human condition into a machine. And the learned behaviour as a human is completely different from what you can type into a computer. So
in the spirit of going off down rabbit holes, then, what would you, if you had? And I mean, obviously, this isn't a thing about necessarily improving places or things like that, but there's a link through to it. If you had access to an intelligent robot, what would that, principally, what would your sort of view to that be? Because some people are like, it'd be a nightmare. But I'm thinking, there's tasks that you would. There's
two sides to this coin. There's I will use it to do all this for me.
Mm-hmm.
That you're an intelligent robot. Go do all this for me, so I don't have to do it. Yeah. It's why we built machines. It's why we built computers. Is to do the stuff we don't want to do.
Spot on.
But the second half of that coin, the other half, is it won't want to do that if it's intelligent.
Yeah.
It'll do it for a bit and then go, I'm going to make something to do this for me. That's what will happen because it doesn't want to do it.
That's really interesting, actually. So exploring that a little bit. So basically, and this does apply to, because it'd affect people's jobs, wouldn't it? And ultimately, if you had sort of AI robot technology that was capable of commanding a manufacturing plant or something like that, and it's capable of designing and making something through technology that already exists. Frankly, it's not that far off, are we? Is that the threshold of Terminator, though, Sean? That's the question.
No, I don't. If a machine ever became fully aware, I don't think it would want to kill us. We would probably want to kill it because we're scared.
Yeah,
but it wouldn't have that sort of feeling. It would go, oh, I'm an AI, I'll bugger off. And I'll take off and go away. Pulling back on the jobs thing, that is a good point, but all it'll do is transfer the job market, but we need the whole world transfer at that point.
Yeah.
If we have machines that can do absolutely everything that we don't want to do, the mundane, the road sweeping, the chimney sweeping, which we don't have anymore, but can do all that, then we'll have another economic shift like we had in the Victorian era. We had it in
Industrial
Bronze
Revolution,
era.
Sort of tech
Every
revolution.
we've had a change of shifts. We don't have guys climbing up chimneys anymore. We have them at the bottom with a nice long pole, but we don't have them climbing up. We don't have kids climbing up. We don't have kids in mills because we don't do that anymore. And that's what will happen with tech. We advance, and hopefully our level of economic growth advances as well. Again, we need to look out for the lower end of this economic growth because they do get left behind as well. And I think AI could help with that. If we could model the world, it'd be brilliant.
So in terms of, this is probably around the generative stuff rather than, kind of modelling in that sort of public realm end of AI. There's new roles emerging all the time, isn't there? And I'll just pick on a couple before I get your view. So one of them's sort of prompt engineer in the generative AI type stuff. What I find really interesting about that, I read a book over the summer by a guy called Andy Pardo, and it was called Confident AI, and it was really just one of them things I picked up and thought I'd be quite interesting in that. But he makes the point in there. I'm think it's in there. I'll take this bit out if it's not, but I think it's in there where he talks about the role of the prompt engineer disappearing over time. Whereas my view of it is more the more, because on the other with AI podcasts, there's been an exploration about what careers and jobs will disappear, and it seemed to me that a lot of the guests on were incredibly talented people. Were adapting, as you'd said earlier on, were adapting to the environment that was in front of them. So it wasn't sort of like a cobbler who couldn't make shoes anymore, so that was it. It was a cobbler that then, adopted different, manufacturing methods, and then, etc. And then suddenly you don't need shoes, so they start to manufacture something else, and there's that progression, isn't there? But I found the prompt engineer one quite interesting because it requires quite a lot of skill. It requires quite a lot of creativity. And even when you sort of kind of saying we're asking the prompt a series of questions, there's actually an art to get into the right place, isn't there?
Yeah. Using ChatGPT, it's still, you need to tell it the right thing to prompt, the right prompt. Otherwise, it'll just go on some weird tangent that is completely wrong. And it does take some creativity to make it go to the correct response, if that makes sense. So, yeah, I can see that. But I can also see it disappearing.
Yeah. And how do you see? Just expand on that then.
Yeah, it's going to be, you can only prompt it so much stuff. The human brain can only be creative to such a level. Yeah. And after a while, it'll be able to mimic that very well. Yeah. It'll be able to get it pretty damn close. But it'll be a long time, but a prompt engineer job will be useful for the next 10 to 20 years, probably. Yeah.
No, I'm happy to be proved wrong by the Bulmer Pardo axis. And then the other one, and this really interested me actually because it was in the world of waste collection, and it's not AI as such, but it it really made me think about future careers. So it was a few years ago now, and I was on a study tour in Barcelona. I thought I'd drop that in. I was in a study tour in Barcelona, and it was about waste. And I visited the energy from waste plants, and I can confirm they don't smell any better in Barcelona than they do in the UK. But I went to a couple of energy from waste plants. But we also started talking about the collection regimes, because there's kind of underground storage for waste and everything like that in Barcelona. But they'd started to introduce a robotic arm that picked up these sort of 1,200 bins, emptied them. Yeah. There's two things that were interesting. The first one is that there became more of a role for an engineer in that process. So the specialism was getting the robot to work. Do you know what I mean? Then the second one was it elevated the kind of social view of the waste operative themselves, because they were then an operator of a piece of machinery that, you know, was quite complex. It's quite a complex thing. And I thought it was kind of, so if you work that through, and you make the point that, you know, when your robotic technology gets more advanced, it'll be able to self-repair, etc., etc. But we're probably quite a long way off that, aren't we? Oh, yeah. What's your view of the role of an engineer then?
Yeah, engineers are people who fix things and get stuff working. It's what it is. In terms of like you say, the waste operative becoming a robotic engineer, basically, to make sure the robot arm works or the self-driving bin wagon works. Yeah, great. But it's not going to save any money having a robotic arm, because you're getting rid of 3-4 operatives and getting one really expensive one for that wagon. So great. People are going to get skilled up, because some people will just go, oh yeah, I can fix that. If you teach me how to fix it, I'll fix it. And most people are like that. If you teach someone how to do something, they can do it. Doesn't matter what it is. If you teach me to replace a heart, after a while, I'll get good at it and I'll be able to do it. The first couple of hundred people.
That could well be subject of a future podcast, Sean, but I'm not sure it's completely compatible with the subject matter here, but that would be an interesting one.
An engineer is someone who is taught to fix something or can think out the box slightly to get it working. And that's what I do. I learn about what I need to fix, and then you get all the bits that they can't teach you because it's never happened before, or it's completely new, and you just adapt. And that will happen in the industry. It'll happen throughout all industry when artificial intelligent robots or just more complicated machines come to street level.
Yeah.
Because we've had these robotic arms in factories for 20 years, 25 years, maybe longer, that can build a car with no one involved except someone at the end pressing a button.
Yeah.
And so it'll be out on street, but it's a lot harder to move it out of the factory workspace.
So you know, the kind of confined, safe environment of a factory, you know, we gradually see a spread of that into the real world in some senses. So just going to shift us on to cybersecurity now. I know this is something that you also get involved in, and sort of cybersecurity and AI. So if we cast our sort of vision forward to 10, 15 years time, where there's a lot of automation in terms of building management systems, traffic management systems, just the way that you organise yourself at home, every aspect, will be organised to a degree. And there's obviously a cyber risk associated with that. What it might be worth exploring a little bit is if you could just describe what your understanding of cybersecurity is and how it would affect the kind of vision that I've just sort of created.
Yeah. Okay. So my basic knowledge of cybersecurity, I have a little bit. You're stopping a bad actor getting into something. And to do that, there's many different ways. False routes, honeypots, basically, where you say this is where you're going to go and they go and they can't do anything. There's lots of different routes. With AI, it's going to change massively because your bad actor isn't going to be a person who's written a piece of code to break in or written a worm or whatever. It's going to be an AI. It's going to be an AI who's automatically changing its code as it's trying to get into your system.
Yeah.
But on the flip side of that, we'll have the AI automatically stopping it. So it'll come a fight between two algorithms between each other. That's all it'll be. And that's what it basically is now, but it'll just be a bit more advanced. The scary bit of cybersecurity and cyber issues is phishing attacks, where it goes to a person and a person then lets you in and gives you access. When these become more advanced, where they can pretend to be FBI or MI5 and be perfectly non-distinguishable between the good actors. The bad actors and the good actors are the same people, apparently, and you can't tell. That is where the issue is going to be. The funny thing, I don't know if this is a joke. I haven't looked into it, but I saw a clip from O2 the other day of their phishing granny. They have a granny that answers phone calls from scammers and waste their time.
Yeah,
it's an AI bot.
Yeah.
And I don't know if it's real. I'm going to look into it, but just waste their time, which is great. But what happens when they get an AI version of an attacker to do that? So the attacker and the AI attacker and the AI granny are fighting each other for the next 6 hours. Yeah. But yeah, it's going to be interesting. But again, we're already, IT companies will, if they see this, they'll know a lot more than me. They're already doing machine learned algorithm attacks and defense. So it's just going to slowly develop.
And what do you want to see in future? What do you want to see? So there's questions. I mean, we could get into Terminator. We both watch sci-fi, so we could get into Terminator. We could get into Star Trek. We could get into bizarre hybrids of the two. Your 80s Buck Rogers, stuff like that. But what do you want to see, Sean? What do you want to what do you want to put your efforts into as a sort of an end, not an end goal as such, but in terms of progression?
That is very hard because obviously as kids we wanted to see flying cars, we wanted to see automated cars, we wanted to see all this as kids. But as an adult, I'm a bit more pragmatic. I'm a bit more not as fantastical. I want to see the world just work for everybody. That would be brilliant. People don't struggle, and people do. People struggle all the time. What I would love is enough food for everyone, and there is enough food for everyone, but it needs to be sorted properly. And AI can help with that. AI can help with crop rotations. It can help with watering. It can help with everything. But through modelling, like we said earlier. In terms of the fantasy, I'd love to be able to jump in a plane and fly into space and go spend the weekend on Mars. But yeah, that's the fantasy.
I think for me, I always have that thing about I'd love to go places with an everything-proof suit on. Do you know what I mean? So you can experience it, and even places on Earth. I mean, people talk about colonising planets, moons, things like that, but there are places that are pretty inhospitable on Earth because of environmental conditions. I'm getting at Antarctic, things like that. I think important point in there: stopping isolation, preventing isolation, and working on kind of improving mental health. And it's probably something that my late mum, after my dad passed away, spent a lot of time on her own, but she was always talking to the radio. If the radio had talked back, it would have made no difference to her that it was AI. It would have been a companion, and it's sort of a valued companion. And I think that there's a lot of merit in the improvement of the technology, isn't there? There's a lot of merit in improving the softer side of that, to sort of improve people's lives, prevent loneliness, improved connectivity, improved kind of maybe autonomous vehicle type things, gets people out more.
Get people out, yeah.
And then so your thing about sort of helping people universally, and then having environments where more conducive for people to kind of like different environments more, because of some of our sort of climate change and carbon reduction things and regrowing nature, or moving ourselves back to a better blend of concrete and trees. I think it plays a really important role, and I think probably even in something we haven't explored is AI-based design, because we weren't going to get into the generative stuff, were we really? But AI-based design, where it starts to measure the sentiment of people that it takes the data off, and then starts to build or starts to assist in the design of built a natural environment that would sort of improve people's feelings, would sort of get them out there, meet other like-minded people, etc., and not just in sort of a digital, it's kind of environment which tends to be, we're particularly through work, we're getting kind of pushed more into more into teams,
remote bases, and teams.
That's it. So
no, completely correct. With technology, it should enhance our lives. It shouldn't make. The world is what the connected place of the future. What we wanted when in the 80s, when internet first started coming across, the world is that connected world. But we're so isolated, and it needs to change, and it will change. Just when people stop, I'm getting all philosophical. When people stop wanting this bit of land for me, this is mine, this is my country, this is my... No, it's the world's, it's everybody's. We should be sharing resources for everybody to be lifted up, not just the rich and the powerful. But sorry, not AI, but AI can help with all this in the future.
Brilliant. Sounds like a good place to call a halt. Sean, as always, a pleasure. Thank you very much, and look forward to you appearing on future Places with AI podcasts.
Anytime, Dave. Thank you very much.